Okay, in this video I'm going to continue on with exercise 7a of the book Fundamental Applied Mathematics. We're on page number 172 and the question is number 12. So it reads, a light rod PQ of length L connects a smooth ring of mass 6m attached to it at P to a particle of mass m attached to it at Q. The ring is free to slide along a smooth horizontal wire. The rod is released from rest in a horizontal position. Find the speed of the particle of mass m when Q is vertically below P. Now, first of all, I found this quite difficult to visualize, and second of all, I think there might be a typo in the answer. So what I'm going to do is I'm going to give you my attempt, which may or may not be correct, I don't know, and if you can see a fault, please tell me, and otherwise that's all I can say really, I suppose. So I've sketched the motion there in front of you, and the first thing I'm going to do is apply the principle of conservation of momentum. So the first mass, 6m times its initial velocity, which is 0, times the small m, which times its initial velocity at 0, is equal to the large m again, or the 6m again, times its velocity, which we're going to call v1, plus the small mass times its velocity, which I'm going to call v2. So we can say that negative 6v1 is equal to v2. Or we could say that v1 is equal to negative v2 over 6. They're equivalent expressions. Next we'll apply the principle or the law of conservation of energy. So what we need to do first is define our 0 point for gravitational energy. And I'm going to define this point here parallel to the wire at the very top to be the 0 point, which means that this energy here gravitationally is negative because it's below the line. So what you'll find first of all is because the speeds at the initial we'll say position are 0, and because I define my 0 point of gravitational potential energy where it is, position 1 is going to have 0 energy. And on the other side we're going to have half mv squared, so it's a half times 6m times v1 squared, plus, or this time it's going to be minus because the gravitational energy is negative, minus 6ml times g, plus half times m times v2 squared minus mlg. Alright, so I'm going to multiply across by 2. We're going to get 6mv1 squared minus 12mlg plus mv2 squared minus 2mlg is equal to 0. The next thing to do is get rid of our m's and just to add what we can. So we have 6v1 squared plus v2 squared turns out to be equal to 14lg. The next thing is we need to get an expression for v2 because we need to get an answer for v2 because that's what we're asked. But we know that v1 is equal to negative v2 over 6. So negative v2 over 6 to be squared times 6 plus v2 squared is equal to 14lg. Alright, so let's just plug out the calculator. So we have basically 6 divided by 36. Oh, we have 6 divided by 36. We have to add 1 to that. Now we're going to get 7v2 over 6 is equal to 14lg. As a result, we find that v2 is equal to the square root of 14lg over 14lg times 6 over 7. And that just turns out to be 12lg rooted like that. Now, however, the answer we're supposed to get is that v2 is equal to square root of 12lg over 7. Alright, so I'll get rid of this here now. So you can see they look kind of similar, so I can't really find out where I've made my mistake, but then again I'm not saying I didn't. So thanks for watching, please pass it on to your friends and subscribe to my channel.